Joyce. That confuses me because whenever I did things for my sister, she wasn't allowed to talk until I said her name.
Yogi soda.
You're not allowed to use that. Right?
That's amazing.
I thought you gotta give him soda. That's only if you say you.
It's not allowed. Okay, so we have a dilemma slightly. We were supposed to get through section 8.4 like yesterday. So
Let's just go speedy now. Go.
yeah, no. But 8.3 we're gonna finish today with volume by shells. Then 8.4 is surface area and arc length.
Ugh. That's what I'm saying.
We're in BC. Can we just finish 8.4? You guys cool? If we do 8.4 tomorrow and Thursday, and then review Friday.
What were we planning on doing? Oh, we're gonna review.
Like we were gonna review, but
No, that's fine.
we're okay. We're good.
What?
I'll try to get some practice problems though, like a practice test, something or other for you guys to work on for extra credit. Is that cool? Just get you some practice problems that you can work on. And then we'll have it like the final review of last year where it can be up to 5 points.
I'll take 12. Wait, what does up to 5 points mean?
Meaning if you do the entire final review I give you,
Yeah.
but if you do like a percentage, we did that for count cards.
I remember that now.
Alright, what's the formula for volume by cylindrical shells?
That one.
It is 2 pi
2
for
pi.
beta d r y h y d y.
Perfect, because it's surface area times thickness.
What's an R?
2 pi r, well it was a p, but it's awkward and I like r because it stands for radius. It's 2 pi r h, which is the surface area of the cylinder. Minus the openings, because we're not doing the openings, like the area of the top and bottom. We're not doing that. And then times thickness to make it three-dimensional, but it's getting infinitesimally thin and accumulating from the integral. And we saw yesterday, perpendicular. If you're doing discs and washers, you are choosing dx, dy based upon. I showed visual aids.
Yes, please.
If we revolve around a horizontal axis, right? Our representative rectangles are going to be perpendicular, so therefore we're going to have dx, right? The thickness is going to be dx for our discs and washers. Because if we have some sort of region, blah, 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 there we go. We're going to do representative rectangles perpendicular. If we have a vertical axis that we're revolving around, and we have some sort of region, we choose the same region, we just have to end it somewhere. We'll end it here. We're going to take perpendicular representative rectangles, which can also be seen by the thickness of the discs, which will be dy, right? Okay. So that's what's going on perpendicular. Whenever we're slicing, we have our pi r squared. We're slicing straight across, we're slicing perpendicular to the axis of revolution, whether it's vertically or whether it's horizontal. Paris shell method says, if we're revolving around a horizontal axis or a vertical axis, and we have some sort of region like, instead we are going to, let's see if I can actually get the shading in. And I can get the shading in. Okay, get the shading in. We're going to slice. Parallel. We're going to slice parallel because we are accumulating cylinders now. So now we're going to have dy. It's going to be parallel. So if you have a y equals, we're using dy. And if you have an x equals, which would be a vertical line, then we are slicing parallel. So therefore, we're having x equals dx, which is a little bit more like our brains would probably think without a picture anyway. We're so used to discs and washers, we're so used to slicing perpendicular to the axis of revolution. It just takes a little reorienting. Does that make sense? The difference between perpendicular and parallel. So then, let's go do an example where we find the volume with cylindrical shells and we find the volume just to compare and contrast with our old-fashioned disc and or washer. Let's check it out. Blah, blah, blah. What we just did, but mine was better. Okay, so this is prettier, whatever, but mine's more straight. Okay. Find the volume of the solid form by revolving the region. There it is, bounded by the graphs of y equals x squared plus 1, parallel shifted up, y equals 0, x equals 0, the two axes, and x equals 1. About the y-axis. let's solve it the old-fashioned way first. We're more used to that, yeah? So, question, would this be disk or washer, pi r squared or pi big R squared minus pi little r squared?
Wash is.
Big R and little R.
Why? Flush, 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 flush. Ooh, I'd be sick.
Oh.
Does that make sense? It needs to be all the way against the axis. Alright, so how would we set up our formula? We know it's going to be,
B equals pi.
I'm doing this quick, sorry. Dx or dy? Dy. Y1 to y2. That's the general, because if we're thinking about it as we rotate around, right?
Wait, Misty, don't need big R and little R?
I was totally doing you. Sorry, you had it.
Yep.
And so if we're actually thinking through, technically these ones would just be solid, right, as they come around. You can see your dy pretty clearly. This one would be still with the thickness of dy. There would be our washer, and we'd have, of course, some three-dimensional component back. Okay. So that's why it's dy, right? How will we plug and chug? Give me the particulars. V equals
Pi.
pi times, what are my y bounds? 0 to 2. And what's my big R?
1 minus 0.
Good. X equals 1. Right minus left, right? So 1 minus 0, which would just be 1 squared. Is that cool? Let's not do the parentheses. That's what mess things up. 1 squared minus, what's little r squared?
Ooh, what do I have to do? Choose a place.
Maybe, maybe not. Why just the positive?
Oh,
I need one side never goes. So I can do right minus left. I'm just going to the axis. I don't need to go all the way, like area between. So then I can have a positive square root y minus 1 minus, 0, right?
Then just y minus? No, yes, just one.
Yeah.
Right.
Alright, does that make sense?
Plug and chug into your calculator.
Plug and chug into your calculator or do it by hand if you need to, no big dealio. Kiddos, does it make a big difference if you put it in your calculator and you use x's instead of y's, but as long as all the numbers match?
I had a question about that because on my calculator,
Yeah.
I did one of the homework problems. I wasn't working.
Yeah.
I guess it must have.
It was 135, right?
It was number 9.
On E2? Right.
No, 3.
And it's just like, I don't know.
Well, the long story short, if you have the proper 0 to 2 bounds in and you have the proper expressions in, the variable is inconsequential, it doesn't matter. As long as you haven't stored like a constant as a variable. So if you were using y and if you had stored y as a number some other time, that might make sense. Oh, that should be
What?
I'll ask you later.
Okay. Let's see what's going on.
I got a non-real answer.
For this?
Oh, yeah.
Put parentheses, right?
1 minus y plus 1.
You're gonna get just y. You're gonna get negative y as your thing. So you have negative pi, and you integrate that, which will be y squared over 2 times negative pi from 0 to 2.
Oh, wait, it'd be 2 minus 1.
Isn't it plus, plus, yeah. So then just, there you go, you can write it.
So try 2 minus 1
It should be
to make sure something didn't input weird. Are you using x or using y?
X. You can see what I did.
Using
You can see what I did.
As I peek at a calculator, how would we draw what's going on with the next one?
Would the bond be different if we were using X and calculator?
No, because you still need to keep it oriented the same way. So all you're doing is saying y, x, a, b. It doesn't matter as long as it's set up right. Does that make sense?
put parentheses everywhere.
Yeah, so do mine, when you say go to, mine into the parentheses.
It doesn't say go to though. So I'm gonna try taking it out. And you use the actual variable button for both of these, right?
Yeah, he's very good.
Oh wait a minute, what if we send alpha? Hey, that right, George, just like the parentheses.
Yeah, and then we delete the parentheses, it goes to the space in between the radical and the square. So I think you just have to get rid of it. I think it's like,
Says it has screws.
yeah, it's probably like freaking out of it, something like that.
With the
Why do we have
skirt,
to do alpha?
I never use alpha in that because I know because the alpha x is a custode and a variable x is different. Alpha is the alpha
Never
stow,
used that.
and then the variable x is just use the variable button. Alpha x is a stowed number.
Oh, well.
I think it's limited. Addition.
Maybe we're supposed to listen to some mechanical, it's not like you, the square.
Yeah, do
That's weird. Okay, first. Alright. First of all, is it dx or dy? And we need 2 pi, so we're gonna need, dy.
No, why wouldn't it be
So
dy?
parallel.
Yeah.
So if it's x equals 0, then it's gonna be dx. I need my x1 to x2. I need my r of x, and my h of x, and I need my dx. Now, I'm gonna zoom in so we can see the picture. Is that okay?
It's R of x, right? Not R
Yeah.
times.
Yeah. R of x.
Why how can you tell that it's a dx?
I don't know.
So if it's revolving around x equals 0, then it's going to be dx. Because when you slice it, you're going to slice parallel. Technically, it's going to be a little bit over. You're going to slice parallel to the axis of revolution, which is going to have a thickness of dx.
Okay.
And that's the representative that we go ahead and revolve around and try to accumulate.
What do they use the shells for? Like
In some senses, it might simplify how you solve volume problems. Because with shells, you're never going to have to split up with bounds. Not only, I shouldn't say never, but ones that you would have to split up the bounds for distant washers, you don't have to with shells. As we think about our radius,
Is there a different, is there like a washer that's different? Like, cause you know how this like this one's a washer technically when we do it that way? Is that?
or do we need to split up? No, because we still have a constant right and a constant. No.
Right, is it?
We have to split up our bounds.
why?
So we have 2 different right lefts.
Right? No.
Yeah.
Yeah, right.
That's why your calculator's probably not working.
Two.
Because we're saying from 0 to 2, and yet,
Because they also want the other ones, right?
what's the equation? Square root of y minus 1, y can't be 0. It's an imaginary number. Why would it split our bounds? Struggle, I even showed the illustration, it didn't even go all the way. Why does this one only work from 1 to 2?
Because that's when the function is.
That's where you have the right, left, up, this, and the curve. The curve doesn't even go below y equals 1, so how can I, on earth can I be asking it to accumulate from 0 to 1? So if you do this one plus, yeah, it makes a lot more sense. Your calculator's not broken. It couldn't do it on real calculation, non-real calculation.
Could you just multiply by 2 is that okay?
Technically, you could just make this a rectangle. Well, but you have to do volume though. You have to do volume. So we're gonna go ahead and just do a disk, right? No big deal. So we can just do 1 minus 0, which would be 1 squared. There you go. Which would end up being integral of 1, which would be y So that's too high, I think, ultimately. And then that will be your final volume. Extortion.
You need to add the part below.
Because we have the accumulation of disks with a right of x equals 1 and a left of x equals 0. And then starting at 1, then I have a right of x equals 1 and a left of x equals 3. So we have to split apart bounds because there are different scenarios going on between these two. Not necessarily
Yeah, no.
that it was disks and washers. Sometimes some functions do skim and then they diverge from the good word, good PC word, they diverge from the axis of revolution. But this one, since there are two different right lefts, we have to accommodate for them. Which shows you then the practicality. This one we had to split up, like we totally got it wrong by doing washers. And I convinced you that it was true, and I convinced myself it was true, and we were all in trouble. This one we had to split up the bounds. This one though is gonna be fine. Why? Because you have top bottom instead, and top bottom stays the same as you go through x equals, what are my bounds gonna be?
0 to 2.
0 to 1. You have to do x's now, right?
Isn't that 2? Oh no.
No. So now from 0 to 1. Let's zoom back into my picture. Question, what represents R? Not that hard. Not that hard.
It would just be the.
Isn't it just the x value minus 0, right minus left? So just like right minus left, x minus 0, no big deal. R is just x. What's my height going to be? Top minus bottom, which is it x squared plus 1? You guys have it? Yeah,
X minus 1.
Go again
Why
first.
is the radius X minus 1?
Because the radius, look at it. The radius is the x value, or any given x value, because we're starting from 0 going to 1. So 0, 0.1, 0.2, 0.3, all the ones in between, it's going to be just that x value minus the axis, which is 0.
But aren't we taking the whole area? So from 0 to 1, and then
Yeah, but remember, my
the diameter
integral,
would be from -1 to 1, wouldn't it?
but remember my integral starts at 0 and goes all the way through. My integral does that. My integral
Also, we want the
moves
radius
through.
on the.
I want the radius of each of the cylinders. So here's the radius for this one. My integral is going to move this, going to be the radius of the next one, the radius of the next one, the radius of the next one. But what determines is all the x values that you give. Does that make sense? But I do minus 0 because if the axis of revolution was like -1, it'd be the x value plus 1. We'll look at this. But doesn't this one just look nicer, neater, cleaner? You didn't have to split up bounds. So that's why cylindrical shells can be nice. What if we were to go to ... plug and chug and we're good, right?
4.712.
Solving either way?
I didn't check out. I'll try that.
But you got
More is higher now.
what was that?
Yeah, I won't do that.
What would it be?
X times x squared plus 1.
1 point something.
I have it. Yep, they're the same.
Can you divide by pi real quick?
It's 1.5.
Oh, 1.5.
Yeah.
1.5.
1.5. But now we should be 1.5.
1.5 even, right? You guys aren't rounding to the nearest 10th, right?
Yeah.
Or 3 halves pi if we're being super snappy. Okay. So then, let's see what you guys can do. Revolving around the y-axis. So is it going to be dx or dy?
dy.
Because you're going to slice. If the slices help doing, right? You're going to slice perpendicular. That's what's going to be the most.
What do you mean h equals y?
But it thinks it's parallel.
It is.
Parallel to dy. Or to the
Parallel to the
original
axis of revolution.
Oh.
Right?
Okay.
Does that make sense? Are my illustrations making sense? The cylinder that represented is what you want.
What is h equal y?
H equals. Oh, and she didn't tell you guys what the answer is.
Damn,
See how far you get. I'm gonna give you 60 seconds. It's not a lot of time, but it's some. Now The nice news is you guys only have 3 in homework. I think maybe 1 or 2 might have multiple parts. Alright, hold on. What are my X values?
From 2 to 4.
That's another nice thing. Because if we were to do this with washers, we have to deal with the hollow, we have to deal with this one, we can just accumulate straight through and say, whatever. The R's and the H's stay the same as we go. So we have 2 to 4. Beginning to end, we don't have to do like a whole nice hollow here. This. My R,
X minus 2.
right?
Yeah. Oh.
The X value minus left is 0. Just
So 2 doesn't matter.
X
Start with 2.
value.
because remember the X value for, let's just do a representative point right here.
Oh, so just xy minus r.
So the X is how far over, the Y is how far up. The X is how far over. It's kind of dealing with like the inscribed rectangles inside, and you're having to think of like X this way, X that way, Y is like what corresponds to the different dimensions of the figure that you're dealing with. So we don't have to worry about the 2 because we're not, the radius is of the entire cylinder. Does that make sense? So we have our X. What's our Y? Sorry, what's our height?
X squared of X plus.
It's Y value, right? And who is the Y value in terms of X?
Can we just do shell all shells the whole way through?
Technically. Except, the AP sometimes gives you those problems where they don't give you all the information, they represent the answers, and you have to answer which one actually accurately would find the volume, or which one would not. So you might need to be able to recognize discs and washers. They might force you to represent it with discs and washers.
I like
Does that make sense?
I don't like my hand being forced. It's my hand.
Close it down. Okay, so, questions, are you okay?
So if you use trapezoidal saw.
Oh.
But they might make it so you can't use the trapezoidal rule because they make the widths uneven. You know what I mean? Coming back. Ooh, it's going on the horizontal one now. But that's okay, as long as we make our representative slice
What?
parallel. Yeah?
And we gotta solve, so it's just y.
If the picture helps, use it. If it doesn't, it's okay. But yes, it is convenient.
We just want one. I feel like all of math is you teaching us how to do something one way, and then it's like not like some of it's super hard, and then like the next level, the next step, you teach us how to do it really easy. That's just all of that.
It's okay, this problem lets you know when washers can, or know when shells can be collected. Dirt
Really,
and discs and washers.
because we don't know what the reason is.
No, the radius was changing this time.
This is always changing. So we have one accumulator.
Oh, I guess I should say that.
So we gotta explain.
So the bound S.
Look at your cylinders as they accumulate. What is your radius each time?
It's, radius is changing.
Radius is 1.
y is 0, because this dy, if y is 0, if y is 0.1, 0.2, 0.3, 0.4, 0.5, right? The radius is how the interval is accumulating, however high, however far it's going out, or being removed from the axis of revolution. However, what is the height of this representative rectangle? This height is 1, or 2 minus 1. Constant height until question. His radius still y, right? The question. What's his height? Right function minus left 1. Wait, y equals 1 over y. Right,
That was Jackie.
oh no, George said earlier 1 over y. It was a while ago. So I have my y's from 0 to, let's see, hold on, what y value is that? 1/2? Yeah. 0 to 1/2, behaving one way, and then I have my y values from 1/2 to 1 behaving the other way. This is when cylindrical shells are going to change. So cylindrical shells, for when discs and washers have to split up bounds, cylindrical shells are better. But for when cylindrical shells have to split up bounds, discs and washers. Because this one would be a simple. When discs and washers would need to split up bounds, shells won't. But when shells need to split up bounds, discs and washers. Look at this one. This one's flush. Having a simple disc problem. Top, always the same, bottom, always the same. So you have to think about for your representative rectangle. Let's fill it in and then we'll talk about how to strategize if you get to choose. For this one, your R is always the Y value, true? Because the R is the height of wherever you are, wherever you're accumulating through 0 to 1/2, 1/2 to 1. Your R is your height. I'm saying that backwards. Your R is your Y. Let me just say it that way. Your height or your length of your cylinder is going to be a constant 1 for this region. Because it's 2 minus 1. It's that constant, just height of 1. Until you hit this one where the R is the same Y. But my height is now curve in terms of Y, which will be 1 over Y. Curve minus boundary, which is 1. So, what was wrong? dy. Right minus left. Right minus left, right minus left, right minus left. They change. Right? Right minus left is 2 minus 1 up until here, then right minus left changes. I don't want right minus left. I don't want dy, so I don't want shells. I want a constant top with a constant bottom. I want disc washers. I want to be perpendicular. I don't want to be parallel. However, if you go back to this other one, you go back to this one, I don't want right minus left because they change. I don't want to be perpendicular. I don't want discs. I want a constant top with a constant bottom. I want parallel approach. Does that make sense? So it all is based on the orientation of what stays the same, right, left, or top, bottom. Now, if they both change, it's big trouble. But we'll just have to use our amazing.
Wait a minute. On that one, you wouldn't really shade what you did shade. You would shade underneath the little under the parabola, right? Because it's dy.
I did change the
No, I mean like, sorry, you would shade under the square root function. So on this side, you would shade like here.
It's all based on the it says curve.
Mm-hmm.
I think about boundaries. It says curve, boundary, boundary, boundary. The only region that's held within definite region that's held within curve, boundary, boundary, boundary is this right. They gave me the boundaries. Does that make sense? So it's not about what makes sense, it's about what is defined, what my parameters are. Is that cool? So what if I was to give you this one? Which one do we want? Oh, don't worry, this is actually a problem that you guys wouldn't have in your homework because it was from the old book. Same with that one. Let's go here then. Let's end here. These are just two other examples. But this one says, decide which is better, which is more convenient. We just talked about the difference between the two. Should we go parallel or perpendicular?
Parallel.
Why?
So you have to choose the boundary.
Well, it's flush. And if you just think about a representative, parallel, right? Which technically this would probably be jutting out just a little bit, so it'd be more like here. What's on the right? Curve the whole time. What's on the left? Axis the whole time. Do I have to worry about switching orientation? Top, bottom, what would you have to do? Top, bottom for big R, top, bottom for little I would have to do washer. It'd be a lot nicer just to be able to do direction. Is that okay?
Would you do like for washer, you have to do the function is the big R and the function is also the little R.
For
Washer.
yes.
Could you just do a disk and have it with the y bound instead of the x bound?
If only it was revolving like this.
Oh, is it revolving? Oh.
So yeah, if we could choose the axis, that'd be great. I would really agree. So then, let's finish off this last one, yeah? Don't find the volume, just express it as a formula. We use what we've been doing anyway, but that's okay. We have our 2 pi. What would our bounds be? Oh no, they didn't give us numbers. They didn't label anything. What are we supposed to do? Ah! Just kidding. Find the zeros, aka the, 0, 0. We're hoping 0, 0. Plug in 0, plug in 0, we have it equal. Okay, that's cool. We're setting x equal, x equal to 0, right? So then setting just x equal to 0 for the other y-intercept.
4.
So we're going to go front. Our radius is going to be? Can you draw it? The draw not working. Beautiful. Radius
So maybe the function.
is going to be y. No, just the y values in terms of y, it's just the height. And then what's the length going to be? Right minus left. Function. Minus 0. What's the only time that it wouldn't be a function alone? What if I was cutting it off over here somewhere? Right minus left would be like this. Cool kids, we have a lot of examples. Go play with shells. You only have 3 problems in homework. Do the best you can to finish up section 8.3, or at least fully attempt it, and we'll see how you do. Sound good?
Oh, shizzle, man. So,
All right. Go team. Need what thing?
First, if you like this video, subscribe, like, and leave a comment in the description below.